Okay, students, let's go through your practice test here. Again, your test will look just like it, just different numbers. So you see this number one's in standard form. The two easiest points to plot in standard form are the x and y intercepts. So if y is 0 and x is 3. Whereas if x is 0, y is negative, 2. I meant if x is 0, y is negative 3. So I plot the 2 points, right? If I don't see 2 points on it, you don't get any credit. You could have 2 points to create a line. So 2, 0, and 0, 3. I see it's solid because it's got an equal sign underneath it. Oh, dang it. And then, yeah. Okay, and then to know where it's shaded, if I look, I can either put it in slope-intercept form, solve for y, put it in slope-intercept form and see it. Or if I'm going to use standard form, I look at the coefficient of the y. And if it's negative, I'm going to switch that inequality. So it's negative, so I'm going to switch it so it's less than or equal to. Okay, it's going to be shaded down there. Now you can also just pick a point. If I pick 0, 0, and if that's true, then I would shade on that side. If it's false, I shade on the other side. So I plug 0, 0. 0 minus 0, 0 is 0 greater than 6. No, it's not. So that's false. So therefore, I shade on the other side again. Okay, that's another easy way for you to check. Okay, here this number 2 is already in slope-intercept form. So we have our y-intercept at -2, and our slope is 1/3, up 1, right 3. There's the second point. Okay, now it's less than, so therefore it's a dotted or dashed line, and it's less than, so it's shaded below. Number 3, write equation in slope-intercept form that satisfies the conditions below, passes through the point 2, -1, and is perpendicular to that line. Well, I need to find the slope of this line, so I solve for y, and I get y equals 2/3 x. It doesn't matter what the y-intercept, I'm looking for the slope. So the slope is 2/3. The perpendicular slope is the negative reciprocal. So that's why you see -3/2 right there. So now I can use point slope form, y minus the y coordinate, so it makes it y plus 1 equals the perpendicular slope, -3/2 times x minus 2. Okay, I can get rid of the fraction by multiplying by the common denominator of 2 all the way through there. Okay, then I need to go ahead and distribute the 3 through, and I get -3x plus 6, subtract the 2 across, -3x plus 4, and last step, divide each by 2, and I get y equals -3/2 x plus 2. Okay, you've got all the work right there. And this is all right from your homework assignments, so you've done plenty of these already. Graph the piecewise function below. Okay, so we see -3 is a key point right here. So if I plug in -3 into here, opposite of -3 is +3 plus 1 is 4. So at 3 I have 4, and then it's if it's less than -3, so that's mean open circle at 3, 4, -3, 4 meant. And then the slope of that line is -1. So there's a -1 slope, up 1, left 1. So it's going to go up there forever. Then it's going to be -2, a horizontal line at -2 right here, from -3 until 2, but open circle at 2. Because again, there's no equal sign there. So it's open circle. Notice this has an equal sign, that's why it's a closed circle there. And remember, in order to be a function, it must pass the vertical line test. So both, let me change the color here. Oops, where's my color one here? This one here and this one here both cannot be closed because it would fail the vertical line test. So notice only this one down here is closed. This one up there is open, so it still passes the vertical line test. That's just a reminder. Lastly, we have 2x minus 4 if x is greater than or equal to 2. So at 2, I plug in 2 into there. 2 times 2 is 4, minus 4 is 0. So it's 0 right there at 2. Closed circle because it's got the equal sign, and it has a slope of 2 from there. Here's my slope of 2. Go up 2, right 1. Up 2, right 1, and draw my ray. And there's your piecewise function right there. All right, number 5. Solve the system below. It says 4x, -4x. I can multiply the bottom row by -1. and that wipes out the x's. I get 5 plus 2 is 7y, and negative 6 there makes it 7. 13 minus 6 is 7. So you get y equals 1. Plug it back into one of those. Doesn't matter which one. If I plug in the top one, it's 5. Subtract the 5 across. I get 8. 4x equals 8, so x equals 2. And I can guarantee I'm right by plugging it into the bottom equation. 8 minus 2 is 6. Yes, it is. So it is correct. All right, solve the system equations below. So we graph them both, and notice that they're both equal, so they're both going to be solid lines. If one of them did not have an equal sign, it'd be a dashed line. But these are both solid lines, both in slope-intercept form, so it should be very quick and easy to graph. Plus 3 right there, and a slope of 1.5, so up 1, right 2, and there's my line. Or I could go down 1, left 2, and connect it, okay? And there's my line. And I have y is less than negative 2x. That's the same thing as plus 0. So that's my y-intercept is 0, and go down 2, right 1, down 2, right 1. Or I can go up 2, left 1. Okay, draw the line solid again. Okay, then it says it's below this line, and it's below this line, which puts it right over here. Okay, and if you want to check, you could pick a point in that region, and it would be true, and plug it in both equations. It would be true for both equations. That's how you can guarantee you're right when you shade. You should be checking a point in your shaded region. See it works, or not just works, but it's true for both equations. All right, number 7, determine if this system is consistent and independent, which means that it intersects in one spot. Consistent and dependent, which means it's the exact same line. Or inconsistent, which means it's parallel, and thus not the same line. Okay, so I could graph both of them if that's what you need to do, or I could solve them for y if that's what you need to do. Okay, and compare their slopes and their y-intercepts and see what it is. Or you can remember on how to check it. I look right here. 3 to 6 is times 2, and negative 2 times 2 is negative 4. So one is a multiple of the other, so that guarantees that they're parallel right there. Now the only question is whether they are the same line or are they different lines. Well, since I had to multiply by 2 there, I had to multiply by 2 here, and that would be 12. If that was 12, that would be the same line, but it's not. So therefore, they're parallel but don't intersect, and that is the word inconsistent. Parallel and not intersecting. Number 8, determine the number and types of roots. This is where you use your discriminant, b squared minus 4ac. Okay, and we check. If I do that, b squared, that's what I did right here, b squared minus 4ac, I got 81. Since that's a perfect square, it's 2 rational roots. Remember, we checked that when we were doing stuff in class today. If it's not a perfect square, then it's 2 irrational, and it's positive. Then it would be 2 irrational roots. If it equaled 0, it'd be 1 rational root. And if it was less than 0, you'd have 2 imaginary roots. Okay. And that is all on one of your worksheets, and you've done it from Algebra 2. Okay. Number 9, solve the quadratic for exact answers. So that's quadratic formula, which is what you see right here. I plug it in, and I must simplify that radical of square root of 44 down to square root of 4 times square root of 11. And then square root of 4 times square root of 11, that simplifies down to 2 root 11. Then I see I have the GCF of 2 between the 2, 2, and the 4. So I divide each of those by 2. I simplify it all the way down so I don't lose a point. And then I get 1 plus or minus root 11 over 2. And lastly, writing following in vertex form. Since this is a 2, I must factor out a 2 from these. And so I have the 2 out front, and I get x squared minus 3x. I divided by 2. Then I have plus a blank, okay, to complete that square. Okay, and half of negative 3 is negative 1.5. And negative 1.5 squared is 2.25, which you see there. But notice I don't have minus 2.25 because I've really added 2 times 2.25, which is 4.5. So I've added 4.5 to it, so that's why you see me subtracting 4.5 from this 2 at the end here. So this is my 2, my It's in the form y equals a times x minus h quantity squared plus k. Remember, that's vertex form. So my a is 2 here. Remember, that tells me the shape of the graph is going to be narrower than your normal x squared graph. And then it's always x, and then half of b. Half of negative 3 is negative 1.5 quantity squared, and then 2 minus the 4.5 is negative 2.5. Notice it doesn't say to identify the vertex, it just says write it in vertex form, so I'm done right there. There is my answer. Okay, so like I said, we can work out problems again in class. If you need extra practice on any of these, I can just make some up real quick. All right, 10 and a half